What it do, E-World crisscrossing wires. Today we're gonna discuss wiring up some accessories like headlights, brake light, or RGB lights. Any type of an accessory that you want to wire up to a switch. And I'm talking about these little switches that are on our e-bikes like this, you know, for headlights or horn. Those little switches aren't very high power switches as far as the amount of current flow that they can handle. Okay, that being said, you should not attempt to wire a headlight directly to one of these switches. Now, can it be done? Is it being done? Absolutely, because some people don't know. Now, they may have gotten away with it, or maybe getting away with it for different reasons. They may have headlights that are actually LEDs, or, you know, use some type of low current. You know, this is 2023. So unlike back in the day where, you know, we had standard bulbs for headlights and very bright headlight bulbs back then for automotive 12-volt headlights, because they were 12 volts, demanded a lot of current. I mean, maybe some of those bulbs are 2 amps, and 2 amps is actually a lot of current flow when it comes to switches. Okay, these toggle switches for our e-bikes, some of them are only designed or capable to pass you know, milliamps, you know, 50 milliamps, 100 milliamps, 500 milliamps, but they are by no means supposed to be passing large amounts of current, 2 and 3 amps. I'm discussing this because, you know, some topics I get a lot of times, you know, watching conversations in different e-bike groups or DIY groups. So yesterday a guy was saying that, you know, when he turned on his headlights or his lighting system or whatever, his switch started smoking. And, you know, I'm not 100% sure if this was his problem, but most likely it was. If not, he could have had another issue, maybe a short or something. But normally it's because, just what I said, these switches can only handle certain amounts of current flow. So if you have, you know, some people have a whole lot of stuff wired up to one switch. You know, they got their lights, their RGB lights, just everything wired up to one switch, you know. Now, some switches can handle high current, like ignition switches, like key switches. Some of those key switches can handle like 10, 15, 20 amps. You know, they're designed for that. But these little tiny switches, they're not actually designed for that. So what you have to do in that case is use a relay. Now, if you don't know what a relay is, let me make sure stuff is in frame. I'm sorry. These are relays. I bought this set of relays off of Amazon. I think it was like 12 in here. Plus, it gives you a nice little harness for it. Back in the day, we used to buy these relays, and we had to make our own wire harnesses, or, you know, actually put those female speaker terminals on there and wires, and, you know, connect them up ourselves. It's nice that they have these little harnesses already made. Now, for most of the wiring that we're going to be doing, these relays have 5 wires on them, okay? The center wire we're not going to be using, so a lot of times I'll just remove that one. Like I already have this one where I removed the center wire, and these relays have terminals on them: 86, 85, 87A, 87, and 30. Okay, so we're going to be using 85, 86, 87, and 30. All right, 87A we're not going to be using. Now, relays are nice little devices. They can do a number of different things, but the main thing they do is pass larger amounts of current. Okay, now these Bosch relays, Bosch makes most relays for the most part. There are other companies that make them, but these relays can handle up to what is it, about 40 amps. Yeah, 40 amps. So they actually can pass a nice little bit of current. So anyway, like I said, we're going to remove 87A. That's going to leave us with 4 of these. All right, now these are 12 volt relays, so it takes 12 volts to energize, open, and close this relay. A relay is basically a switch, but a heavy duty switch that is actuated with power. All right, it uses a little magnetic transformer, little poles in there that actuate when they're given voltage. So, all right, these two, which is 87 and 30, are your signal wires. Okay, 87 and 30 are your signal wires. 85 and 86 is your pass-through. All right, pass-through meaning the current, whatever device we're powering, the current is going to be passing through these 2 points here. Okay, so first of all, before we even do that, this is what I'm using to demonstrate our accessory. It's a little RGB light kit, and this thing actually runs off of 12 volts, and it only takes 12 volts for it to work. You can see if I just give it some juice, you know, hooking the wires up directly to this little 3S 12 volt battery, it will power that device. As you can see, it's on. That's hooking it directly to the battery. All right, now let me get my little alligator clips over here. Now let's say we were wiring this up without the relay. Obviously we would connect the ground of our device to our battery ground. So this is our battery ground, and as far as the positive side, the 12 volt side, we would be using that for our switch. What I do with my alligator these quick. Okay, try to use these to make it convenient. All right, so I'm going to connect the switch up with these little, put these little alligator clamps on there so I can connect it. Now, if we were just wiring up this switch, it would be like that. So this switch is basically in series with our accessory. All right, so our accessory ground is going to the battery. All right, and the 12 volt side is being interrupted by this switch that's allowing our current to pass through it. All right, so obviously when we turn the switch off, it's going to interrupt the current flow. When we turn it on, it's going to allow the current to flow through the switch. Okay, now this current that's flowing through the switch, obviously it's minimum that it can handle this device. It's a low power device, probably a couple milliamps, so it's fine to actually use this without a relay. However, let's say that this device pulled 10 amps. Let's say it needed 10 amps to operate. Okay, so if it needed 10 amps, we couldn't do that because it would burn that switch right on up. So we're going to connect our device back to its ground, put our ground back on. Now over here, I'm using this power supply for our 12 volts to power our relay. All right, now like I said, the relay takes 12 volts to make it actuate. Now here's the leads coming from this power supply. If I put 12 volts to these two leads, you'll hear the relay actuate, open and close. Hear that? So when this relay, when these two wires gets 12 volts, it's opening and closing, opening and closing. When it's closed, it's allowing current to pass through these two pins right here, which is 85 and 86, the same as our switch. Basically the same, doing the same thing our switch was doing. All right, however, because these are heavy gauge wires and this contact in a relay is heavy gauge, 40 amps can pass through there instead of the couple milliamps that could pass through this switch. All right, so now that we have a high power device, we'll be connecting our high power device. Let me get my alligator clips again, and we're connecting that to our battery for our high power device, and it's going to be passing through our relay. So that's going to connect to 86, one side of our pass through, and the other side of our pass through is going to connect to the positive side of our accessory. All right, so basically we're hooking that up the same way that we had our switch hooked up. All right, but now it's not on because our relay needs power to open and close the circuit. So let's give the relay some power. So I'm going to connect my jumper to the ground of my 12 volt power. That's going to connect to the ground side of our relay. Then we're going to add another little jumper down here. And we're going to connect. Let me see, do I have another one of these? I thought I had another one of these jumpers. Okay. I'm just going to connect the wire directly to my 12 volts right here. It doesn't matter which side, obviously, on this switch. But I'm going to keep it nice and neat and connect the red to red. So the other side of our switch is going to go to the 12 volt side of our relay, and that came off. That's why I wanted my little alligator clip, and I'm sure if I look around I'll find it. I had enough to do this. Now the switch is already closed, so instantly it made the light come on. But now, as you can see, when we turn our switch on and off, it's actually powering this relay to open and close. All right. Now, instead of the power that's powering our accessory passing through this switch, it's not passing through the switch now. It's passing through the relay. But the relay is being activated by our switch, because relays don't require high current to initiate. They can activate off a low power, which is why we can use the switch. But we can now pass high current through that relay. So if we were wiring up a whole bunch of lights or some old style filament bulbs that pulled high current, we could now power this lighting system through this relay. All right, just like that. Now, the great thing about this relay is that right now we have our switch interrupting the 12 volts that's powering the relay. But we could also put the switch on the ground side as well. So I could remove the switch from the 12 volt side and connect the 12 volts straight up to our 12 volt side, and it's powering on right now, and interrupt the ground side. So you can make a choice as far as your switch, and a lot of times it's definitely better to use ground to activate your relay instead of positive, because if you think about it, your switch now only needs to be wired to ground. All right, and when you connect it to the ground side of your relay, there's no actual voltage at this switch, as far as you know, it's not sitting with positive voltage. So if this wire were to get shorted, it's not going to hurt anything because it's already grounded, you know. So your device would stay on if it got shorted to ground. But unlike if it got pinched, if it was on the 12 volt side, if your 12 volt side got pinched, it would short out and obviously cause a problem. It would burn up either the wires or your switch or the relay or your battery. It would be a problem if you short the positive side. But because this is the ground side, there's no problem. Your device will just be on, and a lot of times people just run ground to those switches on your handlebars, so that way, you know, you don't have to worry about anything happening to short out your device. So a lot of times it's best just to interrupt the ground. And my little jumper is sitting right here in my face. Well, that's just one of them. Yeah, I think I still needed another one. Don't get old, guys. Don't get old. When you get old, you start forgetting shit, man. You know, I've short-term memory, man. Anyway, this is how you wire up a relay. I will draw a schematic, and I'm going to put that as the thumbnail. And I'm also, matter of fact, I'm going to put the schematic, the wiring diagram for this in the community section on my channel, so you can actually see, you know, the wiring diagram, because this may be confusing, but it's actually not, man. Hopefully I explained that in a way that everybody understood. Now here's another thing. I use two power sources in this experiment. Because everything was on 12 volts, I could have just used one source, all right? Instead of having 12 volts that activated the relay and 12 volts that's running our device, we could have just had one power source, and the 12 volts at that point, the two sides, let's switch this back to, let me put this back on the 12 volt side so this don't get confusing. So we're gonna connect, take this off, connect the ground back to ground, and put our switch on the 12 volt side. Where's my little jumper at? Drop that other jumper again. There it is. Okay. So we're putting our switch back in line on the 12 volt side. All right. Now, because it's on the 12 volt side, I could disconnect the power from this battery and put both of these wires on 12 volts over here. And use one power source. But I'm not going to confuse y'all with this right here, but I will do that in the schematic. But yes, all this could have been running off of one battery since it's 12 volts. And basically, what you would be doing is taking the 12 volt side that activates the relay and connecting it to the source side, the 12 volt pass through side of the relay. Then you would just have this side over here go to your device, this go to your switch 12 volts, and this go to ground. You know, but and that's provided your 12 volts source was heavy enough, you know, supplied enough current to run everything. And if it didn't, then you can't do that. But yeah, so anyway, this just was a quick little you know, quick little demonstration of how to wire up a relay. And I know I'm babbling on and on, but that's what happens when you don't script stuff and you just, you know, do things off the dome. And, you know, on this channel, I just go off the dome. One other thing I wanted to mention in this video, I'm going to start doing some other stuff with my e-bike. Great thing about e-bikes is they can go places where we normally wouldn't go, and other vehicles can't go because they're silent. Now, something else I'm into is metal detecting, and I like finding these old coins. A lot of people don't know that pennies, old American pennies, used to be large, like these, bigger than quarters. These are old copper pennies, large copper pennies. All right. As you can see, that's 1832, and I have that up there because this actual penny that I found metal detecting is from 1832. Okay, this is my little collection of coins that I have loose, that I have found metal detecting over the years. I've been metal detecting for about 10 years now, and although I haven't done what I want to do, is go out in the ocean and do some metal detecting for some serious gold treasures. These to me are treasures in their selves, because you know, this is history right here. You know, yeah. So anyway, these are two of my metal detectors right there that I use. You know, I'm into more than just e-bikes. I'm a gadget guy. I like zoom cameras. I have a lot of cameras that can zoom in real close on stuff like spy cameras, and I don't even incorporate that in my videos, but I have that type stuff. Then I have other good cameras. I have cameras that I could be using to make videos with that I don't implement. Drones and stuff like that that I could be implementing. The only thing that I'm not really skilled at is editing. When it comes to editing, I suck. And that's mainly because I have no patience to sit there, because real editing takes time. And man, bad enough is not enough time in a day to do all the little projects that I want to do. If I was trying to do that and edit these videos, that would take even more time. But like, you know, telescopes, I set the camera up on a telescope and zoom in on the moon. And man, I'm into a whole bunch of other weird stuff that people wouldn't think I'm into. You know, like UFOs and Sasquatch, paranormal shit, man. I'm into all kinds of shit, man. You know, I've seen some little UFOs going around the moon on my damn telescope. You might not believe me, but dead ass. I had some footage. I messed up that footage of my little UFO capture that was flying around the moon. But anyway, yeah, man, you know, I'm a gadget geek. I love gadgets, all types of gadgets. So, you know, I'm going to expand my channel, and I wanted to do some reviews on gadgets and stuff like that. I might end up doing that too, and some other things, man. You know, I just got big goals and big dreams, and you know, I got a whole lot going on, and you know, I'm trying to do too much from time to time. But anyway, at some point I'm going to accomplish everything that I set out to do. But yeah, guys, that's how you wire up relays. Hopefully that wasn't too confusing. And yeah, the schematic will be in the community section. All right, y'all, take it easy, take care. Crisscross and wires, deuces. We out. Peace.